In this video, we're going to see a physics application of the antiderivative. So for the setup, I want you to imagine yourself at the top of a building, and we're going to say this building is some 96 feet tall. So sorry for my non-American friends who usually use meters or whatever other unit you use, but we'll call it 96 feet tall. And you throw a ball up. So up on the top of this building, you're going to throw up a ball. And so this is my little ball. Here, I'll make it like a little baseball or something. And you throw the ball up, and it travels up at a speed initially of 64 feet per second. 64 feet per second. But gravity's pulling down on it, right? So you know gravity pulls things down. So here's gravity pulling down. And gravity pulls down, if we're working in meters, it's negative 9.8. In feet, it's negative 32 feet per second squared, because it's a force of acceleration, right? So gravity is down, negative, because it's down, negative 32 feet per second squared. And I want to know, how high does the ball travel? So I throw the ball up 64 feet per second, but as it goes up, gravity's pulling it down, so it's going up slower, 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 slower until it gets to the top, and then it starts to fall down faster, 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 faster. Okay, so I want to know how quickly, how high up it gets. How tall does this ball go? So if you want to think of a little graph of this, a helpful graph you might have in mind is something like your time graph and height. So at the first instant, when you first throw the ball up, you're already at 64. So you start off at height 64. At time 0, you're already at no, not 64, you're at 96. At the top of the building. So you're already at 96. You're already at 96 feet. But then you throw it up, and it's going to go higher, 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 until it starts going down, 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 down over time. And then it hits the ground, right? So I want to know, how high is this ball at the top of this parabola? How high is the ball? Okay. We will see, in fact, it is a parabola. Spoiler, but it, in fact, does come out to be a parabola. So how high does the ball get? Okay, to see that, I'm going to use the antiderivative. So I'm going to begin by saying, let's call h of t my height function. So I'm going to let h of t just represent my height. So this represents height. Then the derivative of height, h prime of t, we know is velocity, because the derivative is your rate of change. Your rate of change of height over time is your velocity. Your upward or downward speed, your velocity. And h double prime, the second derivative of height, the derivative of velocity, is your change in velocity, which is our acceleration. Now, we don't know the height function. I don't know what this function is yet, but the one function I do know is acceleration, because that's just gravity. My acceleration is just negative 32. At every moment, gravity is pulling down on the ball at negative 32 feet per second squared. And so my acceleration is just constantly negative 32. And so what I want to do is I want to work my way backwards to figure out what is the height function. And so since I'm going backwards from derivative, I'm going to be taking the antiderivative. So I'm going to go backwards from negative 32 to get the antiderivative to figure out what the function of velocity is, what my h prime is. So I go up once doing antiderivative. The antiderivative of negative 32 is negative 32t plus some constant. But what is that constant? Well, here we're going to use the fact that my velocity begins at 64, because that means that my velocity at time 0 was 64. But if you plug 0 into this, you get, well, that's just 0, so that means my constant must be 64. So this tells me that this constant right here, in order to satisfy this initial condition, that my initial velocity was 64, my constant must be 64. So when I plug in 0 for t, I get 64. Okay, so hopefully that's clear how we got that piece. Now we want to do the antiderivative again to go from velocity up to height. So now my t is going to become t squared. It's just like with x's, but I'm using t instead for time. T becomes t squared, which means I need to divide it by a half. So no longer will I have negative 32 up front, but I'll have negative 16. So that when my 2 comes down, 2 times 16 will give me the 32. Plus the 64 will come up as 64t, and just like before, I have plus a constant term. But I can figure out what that constant term is, because if I come over here, I say, when time is 0, my height I know is 96, because I started off on the top of a building that was 96 feet tall. So when I plug in 0, 0, 0, that c ends up being left equal to 96. So I have just c, so that piece should equal just 96. And so I've been able to recover a height function now. By doing the antiderivative twice, by using my initial conditions, the initial velocity, initial height, I figured out a function for height. And now I can answer the question, how high does the ball get? Well, the ball gets to the height, as you can see, this is just a function of a parabola, just as I expected. This is a parabola. The top of a parabola happens at the vertex of the parabola. And perhaps you recall the vertex happens when your x value is negative b over 2a. So the x value of a vertex is negative b over 2a. So the x value of this vertex will be just negative b, negative 64, over 2 times negative 16 over negative 32. The vertex happens at x equals 2. So after 2 seconds. So you throw up the ball, 2 seconds later is when it's at its highest height. What is that height? Well, you just need to plug 2 into the function. So my maximum height would be, just plug 2 into the function, you get negative 16 times 4, so that's negative 64, plus 64 times 2, so plus 128. So that's going to leave me with just 64. 64 plus 96 gives me 160. So your ball gets up 160 feet tall. This is at height 160 feet. There we go. Now we see how we can use the derivative to solve problems like what's the maximum height. There are other questions you could ask too. Like you might want to know, how long does it take for the ball to hit the ground? It took 2 seconds to get to its maximum height. So you might think, well, is it just 4 seconds? Well, not quite, because it took 2 seconds to go from here to here, 2 seconds. So if you go another 2 seconds, your ball should be back down at 96 feet. So it's actually going to take a little bit more. So 4 seconds only gets you to the ball being back at height 96. I want to figure out how long does it take to get the ball to hit the ground. So how do we do that? How do we solve that problem? Okay, a little bonus. Let's slip this problem in. When does the ball hit the ground? So when are we going to hit ground? Well, to figure that out, all we have to do is solve when is the height equal to 0. We just solve when is this height function equal to 0. So that's just solving a quadratic. Negative 16t squared plus 64t plus 96. We're just solving when is that equal to 0. We can simplify this a little bit, pull out the negative 16. You're left with t squared minus 4t minus, oh, did I do that right? 4, so 80, so 6. Minus 6, I believe, is equal to 0. I think I did it right. 6 times 16, yeah, that's 96. Okay, so I pulled out a negative 16. And now I'm just going to use quadratic formula. So I get that my t is equal to negative b plus or minus the square root of b squared, which is 16, minus 4ac, but it's minus times a minus, so it's positive. So plus 24 all over 2a. So I end up with 2 plus or minus the square root of 40 over 2, which simplifies to the square root of 10. Okay, what is the square root of 10? It's a little bit more than 3. So this ends up being 2 minus a little bit more than 3, 2 plus a little bit more than 3. One of the solutions is negative. That would correspond to being over here. That doesn't make sense. It's like going backwards in time. So we just keep the solution 2 plus the square root of 10. It's like 5 point something. That makes sense. We said if we went 4 seconds, we'd be back down to 96 feet. So if we go 5 point something seconds, we hit the ground. It hits the ground right here at 2 plus the square root of 10 seconds. Cool. So all kinds of physics we can do now that we've learned how to use the antiderivative. Just from knowing the force of gravity, we can figure out how high the ball goes. We can figure out when it hits the ground. All we need is to work backwards from acceleration, the force of gravity, to recover a function for a height.